So I welcome you all, and today I'll be giving you a problem for you to try on the topics we have learned and we have not learned, right? That's something you to try. That's actually a very good way to learn like open-ended questions. So I have given you to work out with SAP 2000, and this is the interface of it. And uh, for uh, for your knowledge, I will briefly go through the software today and how to model your specific question, but not with details. I will add those details with later. Okay, so here you have file, and we'll go with new model. Okay, if you want, you can open a existing project, or else you can import Revit files, AutoCAD files, right? So stat pro, I think that's stat pro files, right? So if you have the AutoCAD coordinates saved in DFX format, you can import them. Okay, so likewise there are several files. So I will go with new model, right? So for new model, you will have something like this. So to blank, grid only, beam, 2D trusses, 3D trusses, frame. So the object or else the structure you are going to model will fall under one of these categories. For instance, if it is a beam or if it is a 2D frame or beam, probably you can use this grid structure or this beam, right? Or these trusses, right? So most of the time you will be mostly using this grid only, right? So sorry. So you can use grid only, right? So I will first introduce how to model that grid using that grid. And even that grid can be extended into 2D, from 2D to 3D. That's okay. And this is a predefined frame that you can have already model the frame. And this is only the grid, right? So to model the frame, you can, I will go with grid only. So make sure it's kilonewton meters and C, right? Don't take the other units. So this unit is okay. The same option is default. So I'll check okay. Then the software asks number of grid lines, right, in the X direction. So my frame is a smaller one. So I only need uh, 4. Yes, 4 will be enough. And I'm only defining it in the XZ plane. So I don't need Y direction because I'm only doing it 3D analysis and it's in XZ. Usually because the gravity direction, I think SAP is taking Z direction. It's easy, right? So for Y direction, I can only add 1. Else you can't define the system, right? So in one line, that means it's 2D. So in the grid spacing, I will check 1 meters. So I can make it 1. Doesn't matter, there's only one grid. So here also 1 meter. So the first grid line location is 0, 0, 0. That's the origin. And yes, this is in Cartesian. If you want cylindrical, you can go with cylindrical r theta coordinate system, right? So for now, this is okay. And once you go with this is the XY plane, right? This is 3D view. So both of them are showing the same window. If you do not want, you can close this, and that will be only one window because these windows are sometimes useful because you can see one result from here, and this simultaneously you can check the other result from this window. These two working independently, right? So I need the XZ plane, so I go here and click XZ. So you can see four grids in you can see four grids lines in X direction, and 5 grid lines in Z direction, and one grid line in Y direction, right? It's 2D, so we are working in this plane, right? So there are some tools to select and draw elements, right? So this is bar element or beam element, you can model from this. And quick draw framework variable, so this is to draw a poly area, right? Area element. Mostly this will be used to uh, model, draw area elements, right? And there's option to select all, right? And yes, you can see when I move the cursor here, it automatically selecting the grid point, right? You see it automatically, but we haven't. The reason I took 1 meter is to I can easily draw and compare the results when all things are unique, right? So because in the structural analysis you will be given it EIL, right? So here you can't do that. You will have to so yes. And if you want to, if you want to uh, if you want to see 3D view, you can see within the 3D view you can rotate it and see, right? So if you want to move this window and click your mouse wheel and drag it to somewhere here, right? If you want to rotate it, you can rotate it, right? And I think the arrow keys are also sometimes working, right? So I will move with, so if you want, you have the pan, okay? So you can move it anywhere you want. And these are zoom out and zoom in, okay? So there are display options, okay? And I will move it again XZ plane, okay? And I will model some that a small frame, okay? Let me check. So I'll go to draw. So these things are very important. Within these things, you can edit your frame significantly, and view means it's a 3D view, and the other things grid and axis and everything is here, 3D view, 2D view, and here's to define the materials, okay? To define the materials, right? And this is to draw. These options are here, you can see. And select means if you want, you can select polygon wise, line wise, right wise. So you can assign some, let's say you need to select some sort of some specific members. You can call them a group and select that group easily, right? So this is to assign. So restraint, that means supports. You can see there's a separation linked to joint load. They have drawn a line. So these are for loads, these are for supports and other things, right? And display, if you want to show your show any of your steps, you can loads or what you have assigned, you can revisit from this, right? Design, you don't need this still. Options also, tools, these things you know, but help the contents and index documentation is very important. read that. That's important for your analysis, how to take the output and so on, right? So I will just draw a frame. Okay, so you can see momentary is continuous. Okay, you know what continuous means. Okay, so right, so here to here draw, and I just click here and I just click here. If you want to stop, you can right click. Okay, you can right click, or else you can again draw it like this. When you start from here, and you can see a dotted line going right where your end is. I click here. Still, I did not click right click. Okay, my right click. So so that I can, even if I want, I can go from here, here, likewise I can go, but I will end it here. Okay, so if you want to draw something from here, you can again take it. Don't worry about this window, you can just close it. So go here and click, and my frame is almost done, right? So if you want, you can just, yeah, uh, this is just fine. So now my frame is there, right? But without no supports, right? First thing is I need to add my supports, right? So I will keep a pin support here. Okay, so you need to go to this select mode and select this joint, right? Can you see it's like AutoCAD, right? If you again select it, it will get unselected. Okay, click the same member twice, it will get selected and then unselected. So you remember AutoCAD, if you select something from here, right, only the full element of something full will get selected, right? But so I will clear my selections. Okay, if you draw it with the other way around, if you draw it in the other way around, whatever comes to this will selected. It's like AutoCAD. If you draw it from right to left, whatever comes to the box will be selected. But if you go from left to right, only the full elements, joints are anyway full, right? That's just a dot. If it's in the box, it will get selected, right? See, and the full element, right? So I will clear all. So I need to click this joint, right? I need to assign a pin joint, right? So I will assign joint, right? Joint restraints. So I have 6 degrees of freedoms, right? So if the tick is here, that means restraint. So I need, even if you can fixed, pinned, roller, and no restraint, right? If it is fixed, all degrees of freedoms are restrained, right? So in the pin, you only have uh, anyway, this is 6 degrees freedom means it's in the space, right? Right, you know, already only 2D you have translation 1, 2, and rotation about 1, so it doesn't matter. So you can go with pin support, right? Rotations are allowed. Don't worry about rotation about third and 2 and 3, right? So those are not in the role play because we only working in 2D plane, right? Rotations about second and third axis, you don't need to worry. So for now, I will take it a pin support, right? You can see a triangle is there, right? Actually, it's not a triangle. It's like some shape, right? So, and the first thing is, what is this 1, 2, and 3 axis, right? So, this is the global coordinate, x direction, y direction, z direction. But in the element, they have defined a local coordinate system, right? Always the uh, always the longitudinal axis is the first axis. So you can, even you, if you want, you can see from the display options. We need the elements. Where's elements? Frames. You can see, you can take local axis. You need frames, and to see their local axis, you can see. Just get the 3D view. Can you see? Local axis is always along the member, and that red one is uh, red one is located when your first node to second node. You remember, I draw it from here to here, draw it from here to here, and then draw it from here to here, right? So blue axis, green axis. So these will be 1, 2, and 3. I'm not telling 1, 2, and 3 what are those. You have to find out what is 1, what is 2, and what is 3, right? Depending on that, you can determine what is the output. I will show you at the output. So for now, I will untick it. Okay. So, and yes, again, XZ view. So I will fix it here and here as well, right? Don't worry if you mistakenly, sorry. Don't worry if you mistakenly select elements and joints both and assign restraints. It's anyway, you will be only assigning restraint to joints only, okay? Even if you select, so because we are in joint uh, tab, right? Restraints, so I need to fix it. So where's fixed? That's fixed, right? So you can see, right? So now I need to add some load to this frame, okay? In order to do that, right? Right. In order to do that, uh, first we need to define the material, right? First we need to define the material. So I'll go to the tab and materials, right? So this 4000 psi means concrete, right? So I'll just think this is concrete, okay? So I'll take a copy of that material, right? So you can see our material. This is my material. So weight per unit volume, it's in this unit, okay? Okay. So if you want, you can define what's the unit. I will, if you think it is 25, you can do it, type it 25 and click somewhere else. Then it is automatically mass per unit volume is adjusted. And modulus of elasticity, I think this value is correct. Poisson's ratio is okay. These things you don't have to need to worry, right? It's most of the time weight per unit, raw density, and elastic modulus. Poisson's ratio, I will take it as 1.15. It is not going to affect your results, right? So yes, these things are okay. Our material is defined now, right? It's concrete. Yes, I will go with okay. My material is there, right? So okay. Then I need to define the sections, right? So these are frame sections. If you have cable sections, area, slab sections, those are there, right? Okay. So Then I need to define the frame sections. Okay, I will select. Also, I will add new property, right? So steel, not steel, concrete. So it's a rectangular one. If you want, there are several shapes as well. Okay. So using this is easy, right? But you need to interpret why you use this and so on, right? You need to be able to interpret your results, right? So I will go with rectangular shape. Okay. So this is my uh, section 1. Okay. Section 1, I will just take it 0.2. So this is in meters. Okay. So if unit is not mentioned in this window, so always refer to this unit, kilonewton meters C, right? So 0.2 meters, and width is also 0.2 meters. Okay. So it's 200 millimeters into 200 millimeters, right? So in this here material, you can check our material, right? This is the material we define. Select that. So now this section is under our material, right? So if you select this steel, so this A992, that's for steel. Okay, that's a already there in the system. Don't use it. This is concrete. This is anyway, it is concrete, but we defined it, right? Use it. If you want, you can set modifiers here. If you want to set shear and torsional constraint, these are, keep these in. Remember, this will be useful in bridge designs, right? Not now, right? And if you want to see section properties, you can see cross sectional area, moment of inertia, third axis, inertia, second axis. You can see all of these here, right? Depending on these values, and the material and Young's modulus is here, right? If you need, you can go to material from this plus sign as well, right? Just see modify, you have the values again, right? So material is selected. Now it's okay, right? Section 1 is created. Okay. So I need to now select these 3 frames, so I can go from right to left. Okay. Can go from right to left. So this is our frame, and then we define the materials as well as the sections. Now we only define, we did not assign the materials, right? So it's still, I don't know which section is it. We have to say, like, we have to assign the sections, and section already the material is selected for the section. So we only need to assign that section to each member, right? And then automatically that material will be there, right? Material in the section will be assigned to that section automatically, right? So I will use I will click right to left, so that all of 3 elements will be doesn't matter on the joint, because we are going to assign for elements, right? So all 3 elements I will assign that same member. Assign frame. Now frame, right? Frame sections, right? For frame sections, you can see our section is there, right? Section. So then, okay. So you can see it's showing this section 1, right? So these 3 are in the same section, right? If you want, you can see this extrude fill objects, right? You can see our material is there, right? Right? Okay. So now think about this structure.
our material is okay. Material properties are there already defined under the section, right? So now section is okay, supports are okay. Now I need to add, so define materials, then we earlier draw this, and we now need to, sorry, most of the times for your analysis, go for this load patterns, okay? So you can even create load cases, load combinations, that will be uh, yeah, that will be useful in later. So just go for load patterns. Only the dead load pattern is there, right? So you can even uh, define a new load pattern, okay? Add a new load pattern, sorry. Hmm. Sorry, it's dead already there, right? So what you have to do is, I will go with this load pattern, because otherwise if you want to add, you can just go and add it, right? Duplicate load condition, sorry, load name, uh sorry, is the load pattern name, okay? So I will select new pattern, so then it's a dead load, okay? So those forces are not going to change. Self weight multiplier means within these uh, within these sections, it will automatically calculate the self weight. If you say 1, it's 100%. That means it will automatically calculate the self weights, right? So I don't need self weights. I just need the external loads and the reactions caused by those forces. So I will set self weight multiplier is 0, right? So that means our system does not calculate self weight, include self weight in the reaction. If you want those as well, you can just keep it 1. That's it. Only you need to do, nothing else, right? So for now, I will make it 0 and add new load pattern, right? So new load pattern is there. I said okay, right? So I need to assign now loads. I will assign a UDL to this and point load to this, right? Okay. So for this one, I will apply a load, right? That's a frame, assign, under assign frame loads. So I need to add to the frame, I need to add not point load, a distributed load, right? So this is the relative distance. So relative distance 0 to 5 means quarter, 75 means 3/4, and 100 means the final point, 100% of the length, right? So you can even define a trapezoidal UDL from this. Usually this is given for that. Let me show you. So 1 and 1. So that means at quarter it starts 1, at 0 it's 0, at end it's 0, right? So this is only for uniform, right? So make sure it's in replace, because if you mistakenly add another load, it will replace that and keep your latest load, right? It's not the dead load, it's our new load pattern, right? Coordinate system is global, not local, because we are assigning loads in global XYZ directions. So our Z direction is the gravity direction, right? So it's global, direction is gravity, right? So our gravity is in Z direction, load type force, right? If you want, you can add a moment as well from here, right? And yes, relative distance. If you need, you can select this to absolute distance, okay? Doesn't matter. Can you see? It's a triangle, trapezoidal load. So that's easy, right? Uh, Again, I will add a uniformly distributed load. So distributed load. So I will keep it 0 and 0, right? and I need to add a uniformly distributed load. I will add 2 kilonewtons here, and still replace existing load. So this will be replaced by this new load, right? Make sure these are 0. Here uniform distributed load means everything 2, right? Everything 2. Now let's say you need to add a joint load. Click that joint and assign not frame load, joint loads, right? Joint forces. So what will your force? I would say it's in is a direction. So is a direction is positive is a direction is upward. Okay, positive is a direction is upward. So always make sure it's a new pattern, and coordinate system is global, right? So this is global is a direction, right? So if you say positive, it's in the upward direction. So I will add negative 5 kilonewtons. Okay. So you don't need to worry on this. Will this replace this UDL? No, right? It's a joint force. Whatever early added to that joint will be replaced, since we did not add any joint load to this. Even though some of this part 2 in this joint acting on this joint, that will not be replaced because that's and defined into element load, right? We didn't define any joint load. This is our first load, right? So it's 5. So you can see, don't worry, your UDL will be disappeared, but if you want, you can make it show from this display options. So display load options. So frame loads, new pattern. Okay, so you can see this load is there, and 5 kilonewton load is also there, right? So if you want, you can again replace this load, right? So for this element, I will add a point load to the middle, right? Assign frame loads, point load, right? I will only add a point load. So this will be new pattern, global, everything is there. So I need to add at the middle. So make sure middle is less than 0.75. If you need to add at 0.8, you need to make it 0.8 and add it. So I will make it 0.5 and add a point load of how much? 10 kilonewtons. So don't need to set minus. Okay, it's already in gravity direction, right? If it's in gravity direction, that direction is automatically taken. And that joint load, there was no gravity, right? So they asked the load in global directions, X, Y, Z directions. So if load is in gravity direction, so that means it's minus Z, right? Because Z is upward positive. Okay. So this is, so those two will be disappeared when you add a new load, right? So if you want, you can again show the loads, right? No problem. So for this frame, I will add load, point load. If you want, you can add UDL. So I will add this from 0.3, not 0.3, 0.6, okay, 0.67. So that means 2/3. This is 0. This is, I would say, it's not gravity direction now, okay? It's because gravity direction is Z direction. So I'm adding this in X direction. You can see X direction, okay? So global, but the direction is X direction. Force is in X direction, okay? These are all fundamentals. If you know your coordinate system and local coordinate system well, this modeling is piece of cake, right? So it's global direction, new load pattern, and load is now point load should be in this horizontal direction because it cannot be in vertical direction, so that will be axial load, right? So I will add X direction. So it's positive x direction because I need to add on this way as well. So at point 7, I will add 3 kilonewtons. See, I drove it from here to here. So this is my first coordinate and the second coordinate. Okay, so this is the 0 point and the first point, right? The length, relative distance. So now my loads are there, right? So if you want, you can display your loads. Frame loads, new pattern is there. Joint loads are also there, right? Okay, so now your frame is ready to be analyzed, right? So you can go ahead. So I define the material and assign that. So supports are okay, forces are there. So I can go ahead and analyze it. If you want, you can click run analysis here. If you want, you can set analysis option, and so here also run analysis there. So I will click this run analysis. For now, this model you can do do not run, right? That's not needed for you for now. Okay, so your new pattern and dead load pattern is there, so you can run it. Before run it, you have to save it, right? I will save it frame 1, right? Save it. So sometimes when you save it, it automatically runs. If not, you have to again press this, and then it will automatically be started. So this will show the deformed shape. So you don't. So so you have to see results from these steps, right? These 3 options. So this will show undeformed shape. If you want to show deformed shape, you can just click here, right? So select your pattern. So I'm not going to tell everything. Select your pattern, and if you want, you can draw contours, anything, right? So check these. What are these? Because this is your task given to you to try. Then I will explain in another video, right? So if you want, you can just, so you can check the displacement. We only define joints at these points, so it will only show the joint displacement at for each of 4 joints. It will not show at the intermediate. Sometimes when you right click it, it shows, but not here. If you want to see displacement somewhere middle, you need to define a joint here, right? That means you have to divide the element to 2, right? Define a joint here, that's it, right? Because this structure is solved at these joints, right? So that's something to in the name finite element, right? So you can see u1, u2, u3, r1, r2, r3 is there. So you have to know what is u1, u2, and u3, r1, r2, and r3. That's in this documentation and contents, right? I think in the documentation that's there. You have to read it. How to read this uh, output and other things, right? So I told you yes, let's say one undefined shape, and then I don't need, if you're not if you need reactions, you can go for joints, and my load pattern is dead, new pattern. So you can see the reactions, right? So reactions are anyway in at the joints are in global coordinate system, right? So global xy coordinates, so it will give reactions, right? And it will give x and y reactions because the bending moment can be taken by the element, right? Okay, at the fixed end there should be bending moment, right? That is given in the element as well as the you can see from here. So joint soil pressure is not on. So if you want to see element, this is for the joint reactions, right? So the reactions that you usually solve for, right? So you can go for elements, frames, right? So you have to know what is this shear 2, shear 3, moment 2, moment 3, right? And axial force is there. Our load pattern is dead. And you remember something I told you, 3 local axis, 1, 2, 3. So that's something deal with this, okay? 2, 2, 2, 2, 3, 3, 3, 3. So you have to determine which moment to take, okay? Which moment to take. I'm not going to tell you that. So you have to find that, okay? Display type is force, okay? Because your bending moment is also a force, right? So not a stress, okay? So if you want, you can check axial force, right? If you want, there is 2 shear components. You have to know what is. So when you just go and select those local axes, okay? Those local axes, I will help display elements, local axis. So you have to know. So each of these 3 elements will be 1, 2, 3. You have to know what is 1, what is 2, and what is 3. If you know those 2 and 3, you can easily determine what is this 2, 2, and 3, 3. So you can read the documentation and solve, right? So that's important because these are fundamental concepts you need to know, right? It's local axis system and global axis system. Because in joints, you define the reaction in you show the results in global xy, right? But for elements, it's in local coordinates, right? So it's always in local coordinate system, right? For joints, it's global coordinates. Global xy, it will give the reaction. But element, uh, uh, local axis system, right? So you have to determine what is 1, 2, 3, right? Uh, if you want, you can, even if you need to show values, you can show values here, right? So I will go with the moment diagram. So can you see? So it's giving some nice picture, right? This is your bending moment diagram. And you have to know what is this red and blue, okay? What is this compression or tension? I don't know, right? I'm not going to tell you that. You have to find out that. So if you just uh, take your cursor on this element, it will show the value of bending moment, right? So if you want the whole member, you can just keep the cursor on that element and right click on that point, so that it will give what is that shear 2, 2, moment 3, 3. It will give this value major, right? If you want minor, can those values, right? Axial, you can move this and see. This is from element first coordinate to the last coordinate, right? Location, relative location is there, right? Zero means where you uh, start drawing, right? I think. Okay, so just check it. So then moment shear, you can take the value at anywhere else, right? So bending moment is here, right? Deflection is here, right? Okay, deflection in second direction, right? You have to know what is the second direction, right? So from that you can take the values. Let's call, if this is the end, I don't know what is this M3, I'm not going to tell you. So that M3 value is minus 1.4. The shear is 5.6, right? So you just need to right click on this element, right? So it will show the values, right? Okay. I think it's not the relative. Where are you first? Yes, it's not where you first draw. It's showing the element as it is, right? 0 meters. And for here, is it? No, no, no. It's where you draw. It's where you initiate draw. So the 0 meters means So if you think this is not feasible, so you can just automatic, right? Scaling is automatic, user defined. So you can just, this is very big, so you can just select 0.1, not 0.1, 0.8. So you can see the values, right? So that red line is showing at here, right? So that means that's the 0. That's where we start drawing that element, third element, right? 0. This end is this end, right? This end is this end. You can see that, right? Can you see that marker is going, right? Can you see? It's here. It's here. Okay. So moment and everything is there, right? So always choose, this is new pattern. If you want dead loads, so this is due to the self weight. That's separately calculated. You don't need that. In new pattern, only the external loads are taken. Okay, not the dead loads, right? That's done. Okay. If you need, you can right click on this value and place it somewhere else. So you can see, determine that circle is going, right? That's the point you are taking these values, right? You have to know what is this, right? So from that, okay. So the next important thing is, right? Next important thing is verifying these results. I mean, anybody can model this, right? Even a person without a theoretical background can model this easily. It's not just a very big deal. But what you need to know is whether I can trust this result, right? That's why you have structural analysis uh, to see whether can I trust this, right? Because for a very complex model, you can't use manual methods. That's why you need softwares, right? But for a very simple method, if you can't trust that results, or no, it cannot be. In that case, you can just check whether if it is a simple structure, you can analyze it manually and check it. So from this structure is very simple, right? It's an indeterminate frame, but you can use any method to solve it, right? So solve it and take these, I don't know if it is M3 or M22. I'm not going to tell those. You have to determine what is 2 and what is M3, what is M2, what is shear 2, what is S, these things. You have to know what is these things, okay? Shear 2 to shear 3, and moment 2 to moment 3. You have to know what is to be taken, okay? And these axes, the, know what is these axis, okay? If you know this, if you found the what are these axes, that will solve that problem, okay? So then it's okay, right? So yes, it's done, and all the things are there, so you can determine these bending moments, whether those are true or false, right? This will give you the total bending moment diagram, right? uh, uh, Even if you use some analytical methods, you can calculate the same bending moment diagram, bending moment values, and see whether those results are true, right? Because we did not calculate self weight. In structural analysis as well, we did not consider the self weight. We neglected that, and our mathematical analytical model is also like that. Whatever you saw there, you have to idealize it correctly, and there should be a reason why you do this. So I neglected the element uh, element self weight because we usually calculate structural analysis. We do not consider this self weight during the analysis of bending moments, right? Simple frames, beams, right? So that's why I define a different pattern, and then self weight multiplier is 0, right? So you can't now change it because the analysis has been run. If you want to change the model, you have to unlock it, unlock the model. unlock the model, it will delete results. Okay, then you can again edit the model and do the editings, and again you can run it as it is and check the results again, right? So you can, so the importance of these uh, two sheets is to you can click these sheets and then you are working in this sheet, right? When you are working in this sheet, so you can uh, see another thing, axial force. So you can see the axial force, right? So that's because we have drawn a huge margin. Let's say this is 0.2. It's even bigger. This is very big axial load is in this member, right? It should be, you know the reason, right? So that's it. Now your task is to model this using the method. So one good thing is whether your FEM model, so this finite element model, the analytical or mathematical model represent the actual conditions, materials, loading, everything, the assumption we made. If so, our calculations should be almost identical because the assumption we made are represented in the FE model as well. So that's how we interpret the results, right? Modeling is not the case, interpreting results. That's important. You have to convince your client or someone else why this kind of a force is there, right? So you can just run this application without even assigning the materials. Then you don't know what material is it, but you know you can still calculate the bending moment. Why? Bending moment doesn't depend on the E value, right? Remember? But when you calculate the deflections, that will matter. So those are the basic concepts you have to know, right? Modeling is easy. I'm repeating, modeling is easy, but interpretation and to link your concepts is the thing, right? It's just hardest thing. So I leave you to try that problem, right?